Welcome to the tutorial on analysis of molecular dynamics simulations in Viking. Once you have finished running a molecular dynamics task, Viking provides basic built-in analysis tools to help you investigate your data. The list of possible tools for data analysis is continuously expanding, and in this tutorial we will only illustrate two ways to use it. The first is to study the root mean square deviation of your structure from the initial position, thereby checking whether the structure is equilibrated. And the second is to compute the distance between two distinct parts of the system over time. To illustrate these functions, we will continue to use the ubiquitin protein, which we ran an MD simulation on in the first tutorial. Note that these analysis tasks will rely on the same supercomputer resource that you used for running the MD simulation. If you have not seen the tutorials on setting up and running an MD simulation and adding a supercomputer resource to Viking, we recommend that you watch those first. A common analysis method is the root mean square deviation, or RMSD for short. The RMSD will tell you how far away from the starting position your atoms have moved during an MD simulation. A small RMSD means the structure is close to the starting configuration, while a large RMSD indicates that the structure has changed significantly. Note that it is possible to consider RMSD for the entire protein or some parts of it. This depends strongly on your actual problem of interest. For example, you can use RMSD to quantify diffusion of a loosely bound ligand away from the target receptor. Calculating RMSD in Viking is a simple thing to do. Go to the Results tab in your chosen MD task and press RMSD. Here you can define your RMSD calculation. In the selection box, you type which part of the system you are interested in calculating the RMSD for. It is important that you choose your selection by using keywords known by the visualization program VMD. For more information about the possible keywords, see the official VMD guide. Some possibilities for keywords include protein, backbone, residue number to another residue number, side chains, and nucleic. Here we chose the keyword backbone, meaning that we have omitted calculating the RMSD for the side chains and solvent molecules of our system. The backbone is a natural skeleton for the protein, and therefore it's a good way to keep track of overall shape changes. Now name your RMSD calculation. Select the simulation stages on which you would like to run your simulation. In this example, we are interested in the RMSD for the production stage, which is numbered as stage 4. When you're happy with your setup, press Run. Viking will now analyze your MD simulation according to your inputs. When the calculation is done, you can instantly see the results in the Viking browser, as a plot showing the RMSD as a function of simulation time will appear, enabling you to judge the stability of your simulated system. If the plot flattens out like this, it has likely reached a stable configuration. However, if it doesn't flatten out, like in this example, this can indicate that you need to run the simulation longer. Viking also gives the user the possibility to perform the so-called center of mass distance calculation. This tool calculates the evolution of the distance between two different selections of atoms over time. To use this tool, simply type in two atom selections you wish to monitor. Now type in the name for the calculation. Then choose the stages of the molecular dynamics simulation you want to perform the center of mass distance calculation on and press Run. Viking then calculates the distance between the center of masses of the two selections and shows how the distance evolves over time. In the example here, we have investigated the evolution of the center of mass distance between the C-terminal and the N-terminal, which we have identified by their residue numbers. This is one of the many possibilities that you can explore. In addition to the aforementioned tools, the results page provides information about the total energy which is calculated during the simulation. These results can be used to describe the thermodynamics of the system and indicate how the system relaxes over the course of the 4 stages by looking at the energies which become more and more negative and flatten out. If you click on the plot, you can download it as a high-quality graph. Viking also computes the average energy and energy fluctuations that can be used, for example, to compute heat capacity and other thermodynamic properties of the system. Looking at the temperature, you can see that it has been maintained constant around the value of 300 Kelvin due to the temperature control in the system as was specified in the Viking wizard when you set up the simulation. We hope that you're now ready to analyze the results of your molecular dynamics simulation. Feel free to contact us if you have any questions or problems.